Okay, give me a sec. Let me get your emails. So we have John and Joseph. Okay, it's just the two of you, I think, right? Anyone else? What is issues with it? Grant. Grant. Okay, doesn't matter. Okay, cool. So, okay, this first issue is setting up the fetch itself. Let me get up the okay. Okay, so did the first step work out? And then is it the Catkin make step that's not working? Oh, okay. So let me look at the error that you resource not found, fetch description. Anyone else have the same problem with resource not found? Okay, so can you share your screen with us? Enable that. Joseph. Yeah, I just enabled it. Yep. Okay, can you show me the contents of your Catkin workspace? Can you show me your Catkin workspace, like what's inside of it? Yep. Sorry, hold on. My zoom bar is I can't see the bottom of your screen. Actually, just use your okay, now I can. Can you use your file browser? Yeah. Yeah. Just share a desktop, that way you can see. Yeah. Yep. Okay. So if no one else found any issues with this, I think could you yeah, get your terminal out and delete the fetch gazebo folder in there. Okay. Can you first again install those first couple of packages that are suggested? You can get rid of the slash there as well. Can you type it out? Sudo apt int. You missed D. Just the one that's missing, Ross melodic fetch. Yeah, press dash and see if it gets to come. Yeah. Okay. Can you do that individually, one by one? Use tab autocomplete. So. Okay, so that's installed. Fetch navigation, that's installed. Okay, cool. Git clone the repository. Okay, so cat gimmick. No, not inside source. Yeah. Can you type in sudo apt-get install? Ross melodic fetch Ross dash dash melodic dash fetch dash gazebo. Let's try just installing it from the packages. I wonder what the issue is. Okay, so that's kind of a quick fix, but the thing is, since you'll be you want access to the actual so you just install the package straight away. You have no access to the actual code. You might be you might be okay actually, like you could set everything up in a launch file and stuff, and you get what I mean, right? Like ultimately you'd want to have control over the code, but you can do everything in an external ROS package instead of editing the original fetch code or anything like that. And yeah, and then communicate with this. Yeah, you should be all right. Yeah, if possible, try and locate where this package is, where that you just installed. So it's not in your Catkin workspace anymore. It will be in your ROS path wherever you install ROS. And for example, if you want to edit the gazebo model and stuff, you might have to edit the original file. So to do that, you will have the Zacro file, right? So just go into where you installed ROS and try to find where those original files are. It won't be like you can delete the fetch gazebo package from your Catkin workspace now because you won't be using that. Actually, try running it now. Yeah. No. Delete it and try running it. You can press the up arrow and it will. Yeah. Okay, it's fine. So yeah, the model information should be in some different folder now. It won't be in your Catkin workspace. It'll be on your system. Just for future reference when you're doing your project, try and hunt down where the actual folder is. Might come in handy if you're trying to edit the model, for example. Or yeah, but yeah, everything else you should be all right. You can externally communicate with the fetch using a different ROS package or MATLAB. Okay, so that's Joseph's problem. Who's up next? What's yeah. Could you share your screen? Yep. You should be able to. Okay, just type in ROS topic list. Yeah, so all the topics have been published. Open up RViz. You can just type in RViz. Or you can add your own topics if you want. So if you just you could do that, or so that will be like a saved configuration file for RViz, or you could just add your own topics, right? So there's an option called add. So what do you want to visualize? You want to visualize or you can pick by topic, or pick laser scan, either way, right? And then pick topic and pick the laser scan, right? So you need to okay, so today we talked about transformations, right? You need to mention which frame you want to visualize it from. So right on top of RViz, you can see an option called fixed frame, and it says map global options on the left. Fixed frame. So it says map there. Pick so what you would want to do is see if there's something called base link. That will be the base of the entire robot. Try that. There we go. So if you want to actually visualize the entire transformation tree, say add. Scroll down. This is TF. TF. Zoom in to RViz. So those are all the different transformation axes, right? So right now, yeah, so that's the base, right? So for example, you can now go scroll up in Arvis. You can, for example, change the base fixed frame to say the head of the robot or something, and then you'll be looking at everything. 0, 0 will be the head of the robot. So like today we learned how we can transform coordinates from one axis to the other. So if you change the transformation frame that you're looking from, it will be looked at from that perspective. So that's kind of where it started from. So that's kind of like the external map frame. It's like the external map frame. Okay, so another tool that is useful in transformations is go to your terminal and type, open a new terminal and type in rosrun rqt underscore tf, no, tf3, yeah, and press tab again, yeah, and press enter. Are you running a so that's how each of the frames are kind of linked to each other. So your ROS, basically you can write these basically define these transformation trees so that you know how, yeah, and how each of them are kind of connected with each other, right? And no, you don't. But like for example, ROS has that capability. So for example, if you're making your own robot, you can create your own TF tree, and also for example, let's say for example the arm of the robot is moving, you would want the transformation of the arm relative to the base link, for example, right? So in which case you have to tap into this transformation information ROS is publishing, and you can do that in code. So you have to subscribe to this TF, and you have to get, for example, transformation. It'll give you kind of the transformation matrix that I talked about today between any of these two frames. So for example, if you want the transformation of the torso relative to the base, you can ask for that in code, and it'll give it to you, right? And so you can, this tree helps you understand how everything is kind of related to each other, and any sort of connection between these trees can be requested in code. So this is kind of like the physical dimensions of the robot and all the stuff that the people who designed the robot kind of put in. And you can see that in RVs as well when we visualize the TF, right? Basically all these coordinate frames. By the way, like if it's all messy over there and there's too many frames, on the left side in scroll down, yeah, under TFs you can there's an arrow under TFs. Sorry, there's a no, not that. There's an arrow called frames. Yeah, you can like turn up individual ones. For example, turn everything off. Yeah, and then select base link and select camera. And select camera. Scroll down, get the camera frame. Head camera, for example. Yeah, so that's where the camera is, for example. You can see. Yeah, so for example, now if you move the robot. Yeah, so why isn't the robot moving in the frame? Why isn't it moving around in RVs, for example? Are you moving forward or something, or just rotating? Okay, so but look at Arvis. The base link isn't moving. The scan is moving, right? The robot isn't moving. Yeah, it's all related to the robot. Exactly, right? Yeah, yeah. So if you want to see the robot actually moving, the frame base link actually moving, go up to base. Yeah, change to the frame order, the external frame. Yeah, yeah. So now, yeah, now move the robot. There we go. Now the robot is moving. See? Yeah. This is actually a good demonstration for us to show everyone about transformations and stuff. So I'll actually use this maybe next class. Okay, cool. Does that? Yeah. Mm-hmm. Yeah. Right. So there's a package called MoveIt. That will, so if you go to the Fetch website, it will tell you how to. Sorry. Yeah. So then you'll have to. Then you'll have to basically publish to the topics that MoveIt is publishing to. See, there's a navigation is a bit more complicated because you're using a map and all sorts of stuff. So manipulation, yeah. So that will tell you how to move the arms and stuff. But if you want to move the base, you can just publish a transformation to move the base from one place to another. If you wanted to kind of, yeah, you can tell it to kind of move related to that. Or okay, so you're using Teleop right now, right? Yeah, that's what you're using the keyboard with, right? Yeah, so that keyboard commands are publishing to a particular topic, right? So if you can, yeah. So if you publish to the same topic, yeah, you can. Yep. 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 Yeah, pretty much. In simulation, it will be. It won't be that bad. And yeah, I think it should be fine. Also, you have the laser scan on that, right? That should be far more accurate than RGBD data. It is, but that's all you kind of need, right? Like for example, if you look at the location of your QR code, you don't need all 3D. Yeah, you just need to know how far away it is, right? So, as in, like, once you figure out which pixel in the image represents a QR code, you can then use the transformation. You can transform those pixel values relative to the base of the robot, and then you can ask for the same location relative to the laser information, and then you can get the depth to that, which will be more accurate. Yeah. Okay, cool. Who's next? Is that it? Nicholas and Andrea. You guys still here or just left your computer on? Okay. All right. Okay. Cool. Okay. I'm gonna end the call now. Thanks, guys. See you all next week.